A determinant is a real number associated with a square matrix. I'm going to have to recalibrate. Hold on. A real number associated with a square matrix. Okay. It also has some funky notation. So as soon as I get this back to where it needs to be, where Mr. Polinsky used my board, there we go. Okay. We name matrices with capital letters, right? And so when we talk about the determinant, we're going to put what looks like absolute value bars around it. But since we're talking about matrices, it doesn't mean absolute value. It means determinant. Okay? It does not mean absolute value. It means determinant. Okay? So I'm going to teach you two methods. I'm going to teach you how to find the determinant of a 2 by 2, and then I'm going to teach you how to find the determinant of a 3 by 3. All right? So here we go. The determinant of a 2 by 2, what's really nice is this should look familiar to you. All right? The determinant of A with entries A, B, C, D. So this is just a 2 by 2 matrix. The determinant of A is actually AD minus BC. Didn't we do that yesterday? What do we use that for? We use that was like the 1 over this number for our inverse, right? Okay, well you've been calculating the 2 by 2 determinant for a day now, you just didn't know that that's what you're calculating, okay? So just the criss minus cross, that's your determinant, okay? Okay, so example A. Criss minus cross. What product would we take first? 1 times negative 1, and then we would subtract 3 times 2. So the determinant of A is negative 7. That's it. That's really all we have to do. So I'm going to give you 1 minute, which may be more time than you need. I'm going to give you 1 minute or less to do B and C. Check with your neighbor, make sure you agree on your answers. That word is not allowed. Yeah.
Did you check my homework? Yeah, that's from Friday. Okay. And then that one.
Okay.
Oh, yeah.
Okay, good, thank you. All right, Gracie, what did you get for B? 10. Do you agree with 10? I hear mumbles. Okay, right, we get the determinant of B is 10 minus, careful because something times 0 is 0. The determinant of B is 10.
At this time, we need the following groups to go to the main gym for pictures. College Possible, Education Academy, Esports, and Gaming Club. Again, that's College Possible, Education Academy, Esports, and Gaming Club.
Okay? The determinant of C is 0. The determinant of C is 0. Okay? Let's think about what we talked about yesterday. What would this mean? Okay. So this is going to apply to any determinant we find. If we get a determinant to be 0, then that means that the inverse will not exist. Okay? So if I'm just asking you to find a determinant, that will tell you whether the inverse exists or not. If you get a real number, there will be a inverse of some sort. If you get a 0, the inverse isn't going to exist. Okay? The determinant is 0. You can tell me that, but the inverse doesn't exist. Okay? Yes?
So is the determinant just the numerator of r?
The denominator? Yes.
Yes.
Yes. Yes, it is. I was reading your mind. Yes, it is. Okay? Now, let's talk about a 3 by 3 determinant. Okay? I told you yesterday that you're never going to have to calculate the inverse of a 3 by 3 by hand. However, I will expect you to be able to calculate the determinant of a 3 by 3 by hand. Okay? So let's talk about how we would do it. Okay? So the determinant of A, okay, so I'm going to go ahead and put these slashy bars on my matrix, and our entries are A, B, C, D, E, F, G, H, I. What you're going to do, you're going to take columns 1 and 2, and you're going to copy them right next to your matrix. Okay, so you're going to copy, you're going to recopy columns 1 and 2, just to the right. Either that or I sound like I don't think I said Siri. Columns. Yeah. When I teach sequences in Siri, often my phone will think I'm talking to it, and I have to like be really, really careful. Yes.
So when we do this, do we always copy down the first and second column?
Yes, for a 3 by 3. Okay? So then what we are going to do, much like we did with a 2 by 2, with a 2 by 2 we did Chris minus cross and we were done. Okay? Well, we are going to have to form all of the diagonals for Chris minus cross. So what we are going to do is we are going to take all of the down diagonals. So we're going to take A times E times I and add it to the next diagonal, B times F times G, and add it to the next diagonal, C times D times H. But then can we make any more diagonals with 3 numbers in it? We can't. Okay? So we're going to do it until we don't have any more. And then, just like we did with the 2 by 2, we are going to subtract all of our up diagonals. Okay, so it's still the Chris minus cross, but we have to do 3 Chris minus 3 cross. Okay, so now we're going to do all of our up diagonals. So G times E times C added to the next diagonal, H times F times A, added to the next diagonal, I times D times B. Okay. So you have to multiply 6 times and add some numbers together. That's not that bad. You just have to be careful with your multiplication. Okay. Couple things to keep in mind. Anything times 0 is indeed 0. I know that kind of, you want to laugh at that, but that is a very, very common mistake when we're doing determinants. Okay? So please keep in mind that when you multiply by 0, please do 0. Okay? Also, make sure you group your diagonals together because we are taking these products and adding them and then subtracting the sum of the other products. So put the up diagonals and the down diagonals together in parentheses and remember that there's subtraction in between. Okay? So you have an example, right? This guy right here. We want to find the determinant, okay? So what's our first step?
Rewrite the first and second column.
Rewrite the first and second column. Go ahead and do that for me. Okay, so our determinant, please put these in parentheses so we can group them together. Okay, and we can multiply in our head, right? Okay, what is, and I would even trace it. What is 3 times 5 times 1?
15.
Plus 4 times 0 times negative 1. Ah, yes. Plus negative 2 times 3 times 4.
Maybe 24.
Okay, so those are all of our down diagonals. Then we're going to subtract the group of up diagonals. Okay. So we have negative 1 times 5 times negative 2.
10.
Plus 4 times 0 times 3.
0.
Plus 1 times 3 times 4.
12.
Okay. From here, we just have to add some numbers together. And I don't care how you do this, whether you do one parentheses and another parentheses and then subtract them, okay? But we have 15 plus a negative 24. What is that?
Negative 9.
So we have negative 9 minus 22, right? So our determinant is negative 31. We check our work. Get out your calculator. I'm going to show you how to do this in your calculator. When you have your calculator, go ahead and edit matrix A to be what we just did. Okay, so I know it's kind of like on one page to the next. Go ahead before you switch to the new page. Edit matrix A in your calculator to be the one that we just did by hand.
So will we make that a 3 by 3 or 3 by 5?
3 by 3. 3 by 3. Because it is a square matrix. Edit matrix A to be that 3 by 3 matrix we just talked about. So then if you're back to the calculating menu, if you go to your matrix menu under math, what do you think DET stands for? Determinant. So we can, the DET stands for determinant, and then you would have to call up, you have to call up the matrix in which you want it to calculate the determinant for. And hopefully you get the same answer that we got by hand. Okay. So in your homework tonight, my suggestion would be, when you take a 3 by 3, do it by hand, and check it in your calculator. Just you get the practice of punching it in. Okay, tomorrow we are going to do some review work. We're going to kind of take a time out and practice some of our like inverse and multiplication, this determinant stuff. And then Thursday we're going to move forward with our last section, Now, section 5 is the application of determinants. So what can we do with determinants? Okay? We have 20 minutes left in class today. So instead of like having this boring homework assignment of just like these determinants, I want to start the notes for 8.5 so that on Friday, well, I guess Thursday you'll have more work time. Friday we'll have more review time if we can get some of the notes for 8.5 done today. Okay, I'd rather have Thursday be more of a work day than today. So on the next page, you will see, that right there. But then underneath you have like a table of 3 things, right? Go ahead and make a note to yourself that this is 3.5 material. Okay. So this will be included in your homework on Thursday, but I want to go ahead and give you some of the formulas since we have some time today. Okay? 8.5. In calculus, I'm in chapter 3, and so all right, so we have 3 formulas to talk about. The first is the area of a triangle. Okay, we all know that the area of a triangle is 1/2 base times height. But are there times where we do not know the base and we do not know the height? Okay, if we are on a coordinate plane and we have 3 coordinates, okay, you would have to use some major geometry with like distance and perpendicular slope to try to find where we have our base and height. It could be a very easy calculation. It could be a very, very intricate calculation. Okay? So we have this formula using matrices to where if we have 3 coordinates on our xy plane, we can actually calculate the area by taking plus or minus 1/2 times the determinant of the matrix made up of coordinate xy and then a 1 in the 3rd column. The second coordinate xy and then a 1 in the 3rd column. The 3rd coordinate xy and then a 1 in the 3rd column. Okay. Instead of 1/2 base times height, we can take our 3 coordinates and throw them in this determinant and multiply them by plus or minus 1/2. Why do you suppose we have the plus or minus? Did we get a negative determinant in just the example before? Can we have negative area? Okay, so if you get a negative determinant, you would want to choose the negative 1/2 to multiply your determinant by. If you get a positive determinant, you would want the positive 1/2. Okay? So we have an example just here to the right. Okay, let's go ahead and set it up together, and then I'll have you work on the determinant at your table. Okay? So if I want the area, we are going to take plus or minus 1/2 times the determinant, and it really doesn't matter the order in which you put these in. You just need an xy coordinate and a 1, an xy coordinate and a 1, an xy coordinate and a 1. Okay? Doesn't matter the order, you're going to get the same area regardless. Okay? So go ahead at your table, go ahead and find me without a calculator. Please do this by hand. Please find me this determinant. Okay?
At this time, we need the following groups to go to the main gym for pictures. Global Support Club, Fellowship of Christian Athletes, Circle of Friends, PLUS, Starlight Unified Cheer, Unified Bowling, and Titan Brew. Again, that's Global Support Club, Fellowship of Christian Athletes, Circle of Friends, PLUS, Starlight Unified Cheer, Unified Bowling, and Titan Brew.
Just find the determinant and we'll worry about the plus or minus 1/2 at the end. Okay? Bless you.
Oh, so
Kelly, what are you getting for your determinant? 18? That sound right? Because we should have 0 plus 0 plus 20, right? Minus the quantity 2 plus 0 plus 0. Those should be your numbers. Got it? Okay. So we have plus or minus 1/2 times 18. Which of the 1/2s do we choose? The positive 1/2. So our area is 9 square units. It doesn't give us units, so we don't know what they are, but we know that since it's area, it's square units. So this gives us more practice on now, what would it mean if I set up the area with my 3 coordinates and this determinant equals 0? Well, it's true, there would be no limit. Okay. But what would it mean about my triangle? Would I have a triangle? Like you can't have a triangle with 0 area, right? So instead of a triangle, your 3 coordinates are on a line. Okay. So that brings us to our next table, column, row. It's a row. Okay. If we put our coordinates into this determinant, and that determinant equals 0, then those 3 points lie on a line. They're collinear. So, yeah, we could find the slope from one to the other, and then the slope from the second to the third. But it's also possible for us to put them into this determinant and just calculate. Does it equal 0? Does it not equal 0? Okay? It's kind of nice to have options, right? We can do a lot of cool things with matrices that, yes, we also could do with algebra, but it just gives us another option. Okay? So in this example right here, I'm asking you if the coordinates -2, 4, 3, 1, and 6, -4 are collinear. So we can put these into our matrix xy1, xy1, xy1. And remember, it doesn't matter which order the coordinates are in as long as they're xy1, xy1, xy1 for your rows. Okay? So go ahead and take about 30 to 60 seconds and calculate this determinant for me. Pick your work with a neighbor. Oh, like, okay. Can you write it next? I just want to see how you write next. Just write it. Oh, that's why you write it. Like, I write it next like this. And you write it. That's how you did it? Here, write it so I can watch it. That's better. How about this? Start at the top left. Okay. We always start at the top. I know. It's just, yeah, because I was gonna say how like you write it next.
Do we multiply this one by 1/2?
All right. Sorry, I'm getting distracted by the outfit. Okay, so we should have -2 plus 24 plus -12 in that first. Okay, which gives us, what would this be?
10.
Okay. Minus, okay, our up diagonal should give us 6 plus 8 plus, plus 12, which would give us 26. And so -16 is our determinant, which means, are these points collinear? No. Since this does not equal 0, then our answer is no, they're not collinear. Okay, that's what this means. If our determinant did equal 0, then those three coordinates would be collinear. So, let's take that a step further. Okay? Yes.
Are we ever going to drop these?
No graphing in chapter 8. Woo-hoo. Or chapter 9. Okay? We will not graph until January. Well, take it back. You'll have to graph on your final. But
Like only one problem on our final?
I don't remember. Okay? Alright, so let's say we have two coordinates. Okay? Yes, I know we can use algebra. We can find the slope between the two lines. We can write y equals mx plus b and figure out what b is. Well, we can also use the fact that that determinant equals 0 means we have collinear points. Okay? So, what we can do is we can say, all right, well, if I have 2 points and I want them to be aligned, I'm going to use this matrix that I know needs to equal 0. And my first row is just going to be a generic xy with the 1. And then we can put in our 2 numeric coordinates for the second and the third row. And we can use our determinant to help us write the equation. Okay. So in our example, I gave you 2 coordinates, right? So if we want to use a matrix to write the equation of the line, which is what I would expect on Wednesday's test, I know you can do it with algebra. We're going to do it with matrices, okay? We're going to write x, y, 1 for our first row. Then we can use our coordinates. So one of our coordinates is -3, -1. So -3, -1, 1 is our second row. And then our third row would be 3, 6, 1. And if these are collinear, we know this would need to equal 0. Okay, so now we find the determinant. Okay? So the only thing that's kind of strange about this is that we're going to have products that involve x and y, but we are writing the equation of the line, so I hope that there are some x's and y's in there. Okay, so our determinant is x times -1 times 1 plus y times 1 times 3 plus 1 times -3 times 6. Okay, minus our up diagonals, 3 times -1 times 1 plus 6 times 1 times x plus 1 times -3 times y. And we know that we want this to equal 0 because we have collinear points. We're writing the equation of the line. Okay, so now we can combine like terms. We have -x minus 6x. Okay, we have 3y minus -3y. Okay. And then we have -18 minus -3. Minus 15? Is that what you said? Okay, so from here I really can be pretty flexible. If you leave it like this, I'm fine. Technically, standard form would mean that x is positive and that your constant's on the other side. So you could write this as 7x minus 6y equals -15. But really, I'm okay either way. Okay, so your homework assignment, it really shouldn't take you very long because it's just determinants, okay? These problems right here, you will see on Thursday's homework assignment, okay?